Hello everybody. Today we'll be discussing about trigonometric identities, the part 5 of the trigonometry chapter. So yeah, in the previous video we have discussed that sine square theta plus cos square theta equal to 1. But we don't know how. So we will derive this from Pythagoras theorem first. So there is a triangle and which is having a theta, A, hypotenuse and B. So according to Pythagoras, h square, which is the hypotenuse square, equal to a square plus b square. A, b square. Yeah. So sine square theta plus cos square theta equal to 1. We have this and we have to prove this. So what we should do, we know that sine theta equal to a by h and cos theta equal to b by h. When we square this, sine theta, sorry, so it becomes sine square theta equal to a square by h square. In the same, cos square theta equal to b square by h square. H square, I forgot this. Yeah. Now we have to add it. So sine square theta plus cos, I forgot theta. Sine square theta plus cos square theta equal to a square by h square plus b square by h square. This is a. Yeah. So now same denominator, the a square plus b square adds a square plus b square by h square. Now we know that h square equal to a square plus b square. So a square plus b square by a square plus b square. Same numerator, same denominator, it's cancelled. Check out. The answer is 1. This is how sine square theta plus cos square theta equal to 1. So this is the first trigonometric identity, and we have remain like the previous three, but they are not so important. But this is the first and the foremost important trigonometric identity in the trigonometry chapter. We'll discuss the remaining two. So the remaining two are also easy. The second one is secant square theta, not plus, minus tan square theta equal to 1, or we can write this as secant square theta equal to 1 plus tan square theta, where here a rule applies, a rule for theta, where theta is not equal to 2n plus 1 into pi by 2, which means theta should not be equal to 2n plus 1 into pi by 2, where n belongs to integers. We know integers 1, 2, 3, 4 and minus 1, 2, 3, 4, etc. And now what does this 2n plus 1 into pi by 2 represent? 2n plus 1 into pi by 2 represents that the odd multiples of 90. Yes, 90, 270, so on, so on, so on. Where theta is not defined for secant and tan. See, tan 90 is not defined, secant 90 is not defined. So if 90 comes not defined, we don't know what is not defined also, because it's not defined. Next. Yeah, so done. Third one. See, here in place of secant there will be cosecant square theta. In the place of tan there will be cotan. It will be coco minus cotan, cot square theta equal to 1. So cosecant square theta equal to 1 plus cot square theta. We have another rule for theta where theta is not equal to n pi. Simple. Because cosec n pi is not defined and cot n pi is also not defined. Matlab cosec 0 is not defined, cosec 180 is not defined, cosec 360, cosec so on is not defined. And where n belongs to integers, the same. Because n is always an integer. N cannot be a rational number like pi or something else. N must be an integer. So these are the remaining two rules, which are pretty easy, but there are a few limitations for theta. Whereas in the case of sine square theta plus cos square theta equal to 1, there are no limitations. Theta can be anything. Yep. So it's done. So these are the two other important trigonometric identities. Give me a second. Yeah, these are the two important trigonometric identities. Now, if we expand these trigonometric identities, what do we get? See, if we expand this, secant square theta minus tan square theta equal to 1, right? So, a square minus b square equal to a plus b into a minus b. This is from algebra. Everyone, everyone must know this if you are listening to this lesson, right? This is an identity in algebra. A square minus b square equal to a plus b into a minus b. So we'll apply the same for secant square theta minus tan square theta. So it will become secant theta plus tan theta equal to 1 by secant theta minus tan theta. Or reverse. Secant theta minus tan theta equal to 1 by secant theta plus tan theta. It's like reverse. Anything can become anything. Same limitation where theta should not be equal to 2n plus 1 into pi by 2. I've just explained why. And n equal to integer. We don't need to write that long. Here. And guess this is the same. I'm not going to write it. So it's a cosec theta plus cot theta equal to 1 by cosec theta minus cot theta. Clear? So this is the expansion. I mean the next level of the same identity. That's it. So yeah, these are the trigonometric identities and these are the expansion. This is these three. This and the sin square theta plus cos square theta equal to 1. They are the most important trigonometric identities and the base for the remaining trigonometric identities in the trigonometry chapter. We have hundreds of trigonometric identities in trigonometry chapter, but yeah, these are the most important. Next, we will be moving on to some more trigonometric identities. Sorry, I had to fill my ink. Now, next, we are going to be learning a few tips, kind of for the trigonometric identities we have previously learned. So let's name it note. So note, first one, sine n pi equal to tan n pi equal to cos 2n plus 1 into pi by 2, I mean the whole thing should come in brackets, equal to 0. We know that sine 0 is 0, sine 180 is 0, sine 360 is 0, and the same with tan 0 0, tan 180 0, so on. And this cos 90, cos 270 and cos so on is also 0. It's like kind of a shortcut for advanced trigonometry. When they give bigger trigonometric values, we can directly do this. Okay. And in the second note, we have sine 2n plus 1 into pi by 2 equal to minus 1 whole power n. And the same, but cos n pi equal to minus 1 whole power n. So these are the 2 points in note, where sin n pi equal to tan n pi equal to cos 2n plus 1 equal to 0. And sin 2n plus 1 into pi by 2 equal to minus 1 power n. And sin n, cos n pi equal to minus 1 whole power n. Where, and in all cases, where n belongs to integers. That was quite a suspense. Where n belongs to integers, always, and always belongs to integers. So if, for example, we'll take for this sine, we'll take n equal to 2. Okay, so sine 4 plus 1, 5 pi by 2. Right? 4 plus 1, 5 pi by 2 equal to minus 1 whole power 5. So minus 1 into minus 1 into minus 1 into minus 1 into minus 1. So this thing is minus 1 whole power 5. Which means minus 1 whole square into minus 1 whole square into minus 1. So minus 1 whole square is 1, 1. And the answer is minus 1. That's it. And this 5 pi by 2 we have to calculate. So we'll calculate 5 pi by 2 is nothing but 5 into 180 by 2, 5 into 90, and that is 45. So sine 450 degrees equal to minus 1. So we have got sine 450 using a short method, using this much, using a small integer, right? That is the power of note. Thank you. And tomorrow we'll be discussing more trigonometric identities, like more shortcuts for calculating bigger angles and more problems in trigonometry. Thank you. Stay tuned and please do subscribe if you like the video. Please like it and leave a comment and share this video. Thank you. Bye bye.